So welcome to this webinar. We are talking about Libra under the hood. So all the things that we are saying this morning, it's all about the Libra project. So let's see this introduction video. Then go to the protocol specification. If you want to looking for a specific protocol specification, there is some videos out there for find the protocol specification that are you find. So let's move to see this video.
Remember when these were fast? And these? Technology has improved the world around us. So why is it simple to send one of these anywhere in an instant, but not money? What if we made money truly global, stable, and secure? What if everyone was invited to the global economy with access to the same financial opportunities? Introducing Libra, a new global currency designed for the digital world, backed by the belief that money should be fast for Ope in Lagos, simple for Saul's family business in Manila, and secure for Betsabé when sending money home to Mexico City. It's powered by blockchain, making it safe and accessible, no matter who you are or where you're from. So join us as we move towards a world where money works for everyone. This is Libra, and it's just the beginning.
So let's to see the protocol specification that it's the chained BFT. So let's to move to the developer area to look what is this protocol specification. That is basically how this protocol specification is connected. So let's to see this protocol specification under the hood. So we have here the hip. So there is different folders here, and we are talking about the consensus folder. That is the BFT protocol, and we see another videos that the Libra protocol use a variant of the Hopstop consensus protocol. So basically, this is the Libra from scratch. So let's see this paper to understand the basics about the Libra protocol specification. We saw in other videos that this is a leader-based Byzantine fault tolerant application protocol for the partial synchronous model. So far, this partial synchronous model is the thing that this kind of protocol specification is dealing. So this protocol are this protocol is the thing that needs for the scalability challenge. So what is this scalability challenge? So far the scalability challenge are the transactions per second. So transactions per second is the number of the transaction that you have in the network in a 1 second. That it means how many transactions the block can handle in a safety way, of course, because this data needs safety conditions, safety rules for split the meshes correctly. And this is because the correct consensus have three main ingredients that are the agreement. That means that all process decides to choose the same value. Determination, all non-faulty process eventuality decide. Validity, the common output value is an input value of some process. So these three main ingredients for this kind of recipe is because the Fisher-Lynch-Patterson FLP impossibility demonstrate that there is no deterministic protocol that satisfies the agreement termination. So far, this agreement termination that are in another sense calling the not trivial area that the researchers divide for reach the consensus and not reach the consensus. So this not trivial area for the analysis of this science, it's only an extension to the model in a way for reach the consensus. So far, this is interesting thing to understand the protocol under the hood. So let's move to see this protocol specification that is calling the chained BFT. That basically is the pipeline of the Hopstop protocol, and so far it's the variant of the Libra implementation. So we saw here the first chained Hopstop, and it takes three phases for a basic stuff leader to commit a proposal. In the mean of the protocol specification, the basic stuff leader is the node. So in this extension of to the model that it's a permission net model, the leader is the node. So three phases are not doing useful work except collecting votes from replicas. So this is the function of this leader, and they are very similar. So far, this chained Hopstop improved the basic Hopstop protocol. So we're talking about two kind of protocol: the basic Hopstop and the chained Hopstop. These two protocol, it's the way to connect in a faster way the consensus specification of the protocol specification. So let's move to see this chained Hopstop, and you can find here the figure on the algorithm. It's here. So we saw in another videos the code of this. So let's summary this large algorithm for understand how this protocol works with the basic Hopstop. So far, the basic Hopstop is the thing that is very similar for the PBFT protocol. That is the practical Byzantine fault tolerance. So let's see this algorithm. We have here the first line, that is procedure create a leaf. So far in a leaf, that it's all about the tree. You have parents and childs. So, but in this specification, you have this Kirum certificate. So far, you can see here that this Kirum certificate, it's a package of data that have the CMD3 and the CMD2 and the CMD1 so long. So far, it's the way to connect this kind of protocol specification. So let's move to see more of this. So the input here is create this leaf with this condition. So the parent with the thing that you need to return, get the branch extended with blanks from parent to head curve view. Then this CMD get the CMD. Then this justify, get the keyroom certificate, and then return. So far, you have in this first part of the algorithm, it's a pre-generic phase in some way, because you are prepare the leaf that you want as you want, with the condition of CMD on QC that you want. So this is for having this view and get the things that you need. So in the generic phase, we're talking about as a leader. We can see so far this in the code. So let's open so we have here this folder. It's a consensus. In the source area you have the chain BFT, and you have different things about the chain stuff. So far, for create this leaf, you need to make a lot of technical way for doing the work that this algo needs. So far, this process needs handle different things for make a not buggy code. So you can find here the way for implement this, that you need to pre-process all the things. You need helpers for this thing. You need to sync up this because there's missing dependencies for the keyroom certificate and the ledger info. So you need to handle all this data with a technical way, not just the algo over there. So you also need to process all the local time now to have a good broadcast. Then you need to back out votes. So there is a lot of process that you need to reach the consensus in a not buggy way. So you need to process the certificates of the keyrooms. So you also need the process proposed block. So if you are a Rust developer out there, you know that this is a functional program, so you need to find the functions in the functional way. So you have this algorithm that basically do the create leaf, and so far you have this generic phase for the leader, and then finally that is only the next view. So this next view is send messages to the leader with the conditions that you are trying to do in this algorithm. So far you need this kind of helpers and this process for make a better development. So you have here execute and vote. That's the function generates a vote message for given proposed block. You also have to process these votes with 3 conditions to help a better performance. You need to add a vote. So all the things that you can see here, it's in this algorithm, but under the hood you need these helpers for this statement. You need to help this statement. So this is extra ingredient if you want to make a real world implementation. So this a tricky part of develop blockchain, and also the hard part of do a blockchain is reach the consensus, because you are dealing with different impossibilities. That in this chain is the Fisher-Lynch-Patterson impossibility for dealing with a single failure. So you need to find a way to deal with this. Then one would be the randomized protocol. You need to randomize your protocol, make a randomized input. So there is a lot of extension of this kind of model. For example, in the Casper implementation, they are use the RANDAO and PDF. That it's all about make a slot random, and it's for protection for adversaries and also for the impossibility. So it's interesting thing for dealing with this kind of consensus. So let's see more these processes. So far you need to process all the things that you have in Algo, and you can find that this is a large code here for understand all the function that this kind of protocol has. So let's see more interesting things. Let's see the liveness effect, that is all about membership. So this membership is leader reputation. So in this is heuristic reputation heuristic. So this reputation heuristic is to calculate weights for proposers based on a story. So you have here the reputation heuristic, and let's do this code for understand the properties that this heuristic thing have. So let's see to the code. So you have here the heuristic. So you have this proof trade, reputation, heuristic. So you need to have the function and you need the self candidates, then the author, proof trade, reputation, and you need the author that we saw in another videos. That could be the ID of this. So it's based in the story, so you need the base. So far you need the block metadate. That's a way for handle this protocol specification. So if you have a lot of expertise in databases and you are an incredible developer in the Rust programming language, this is piece of very familiar, because you have to handle all the data with the helpers, you need to handle all the data with the process. But this kind of thing, that reputation heuristic, activate inactive heuristic, it's a specific thing in the BFT protocol implementation. So you have here this. Let's see the pop struct. Active inactive heuristic. So this weight thing, it's very similar with the height function in the Casper protocol implementation for find a justificate chain for the supermajority of of the Casper FGG for reach the consensus in a safety way. So let's see this thing under the hood to understand. So you have this activity. So this inactive, you need to vend this for make a better understand of the protocol. I mean, this is experimental code, so there is a lot of things that you need to figure out. So you need to make this implementation. So this new function is about to activate the web function that is based in the story. So far this inactive wait is also the same kind of data. So you have this self thing. This self thing is active wait, and you need to vend this. So far you can find here this heuristic thing. So this replication of this code is for understand this heuristic thing for the reputation mean, because in the algorithm you have here this, that as a leader you have a current view. So M is the set of measures collect for the end of previous view by the leader of this. Remember that in the BFT protocol it's all about the measures, how to pass these measures and split the measures in a correct way for reach the consensus. So it's a tricky part to figuring out all the things that you have. So we can see here that it's very similar with the Casper implementation in the ArcMax, only that you have no justified view number. You have in the Casper protocol specification a number of attestations. That's the thing that you need to justify. But in this means you also have the high quorum certificate for our good mess. This justified view number, and this is a permissioned setting. So you need the architecture of quorums, because you can make that the quorums do in the permissioned setting. So you decide what is the high quorum and what kind of validators can join in your network. So it's a protocol specification for the protection in the permissionless setting, and it's very similar for the Casper. So you can deep dive in the FGG Casper, or maybe in the Casper basics, and also in the Sobolovsky Ghost paper, and you can find that it's the same way for reach this consensus, and it's dealing with the personal synchronous network. So let's see that you have start a membership thing. So if this condition with the view number that you have is more that the generic quorum certificate with the view number, then this generic quorum certificate gets the high quorum certificate, and this is the way for connect the current certificate. So in a fig you can see that this is this step in the pipeline basic hub stuff. But remember that you have this basic hub stuff and you have this chain net BFT thing. So these two protocol, it's because you have a mesh topology, and this mesh topology it's very difficult for handle the protocol specification. And so far that the reputation heuristic and the activate and inactivate heuristic is a kind of helper in the technical way for make a better performance in the blockchain approach. So let's see more things about this, and let's replicate this heuristic because it's very experimental for this kind of protocol implementation. So you have the implementation, reputation heuristic for activate, inactivate heuristic. So you need the same height, get these weights that is very similar for the height function in the Casper implementation. So you need to make a democratic way for reach the consensus. So you have these candidates, you have the author, so you need to start thinking in the condition of this. So let's set the story iter to fold the hash set new, and so far you need the same thing here. And it's because you need to handle all these heuristic things for make a better code. So this is so experimental. So you need to insert the things. So remember that this kind of code is not so friendly. So if you chain one variable in this code, all the building blocks of consensus fail in a crash or in a big Byzantine failure, any kind of problem that you are not expecting. So it's allow of the resilient mean. So you need to have a better protocol specification. So you can see that this reputation heuristic for this Venn heuristic, that it's one part of the activate heuristic and one part of the inactivate heuristic. So you need to map this for handle these two kind of interpretation in your code. So you need to do a statement of this. So then then collect all. And so far is this the implementation of the reputation heuristic for handled the Venn thing of this leader reputation thing. So all is based in the commit story for the proposal election implementation. So you have here the structure of this leader reputation, then all the data is the heuristic thing that is based in this kind of condition of the reputation heuristic, and also the proposers, because there is no leader if there is not proposers. So this implementation of the leader reputation with this kind of input, you have that the proposers are vectors of the actor for make an ID reference. You also need to backend this metadata for handle all the data that you have. So this is a technical way for make a better code, and the heuristic is the same kind of input. So this kind of data needs all the data that the struct of the leader reputation have, and then you need to propose the election. So let's replicate this code because it's an interesting part for understand the algorithm of chained of stuff. And these are the conditions for the liveness setting of the BFT protocol implementation. So let's move on. So this proposer election for leader reputation if it's valid proposer, have the self author have the round, then another round. So it needs to be an option. The author setting. So if a self get valid proposers, it's wrong, contains the author, some author, then else none. And so far you have this valid proposer. So this kind of implementation is very slow because you need to handle a lot of data, so don't expect write this code so fast. So maybe you lost a lot of time only getting the name of the functions. For example, the proposal election function implementation, or maybe the function of get valid proposer. You need to think a lot for only the name of this function. And this function could change, put more data, and the obvious thing is connect the protocol, right? So, but maybe not the obvious thing is how to reach the consensus in a faster way for the protocol specification. So there is a lot of figuring out. So let's move to see more things. So remember that in the algorithm of the chain of stuff, finally you need to next view interrupt, go to this line. If the next view is the current view, it's calling to that, wait for any phase of these measures. So it's all about to finalize this and start thinking in this validation. So you have here the function of get valid proposals. So in this get valid proposals, you have here the configure the wrong gap. So remember that you have the heuristic. So this is a very hard part for debug this and make a good code, because remember that you have this experimental thing, this reputation heuristic is the name of the function that the principal the principal thing that this kind of function do is bend this inactivity heuristic and the active heuristic. So to validate this process, you need the wave function in some way, because you are connect these blocks in the ways that have. So you need to heuristic this wave function for make a better performance in the way that are connect. But the current certificate have this arc max. So this current certificate decide for the recursive algorithm here and the way that reach the consensus, because it's all about this current certificate and justify all the view number that you have. So if this current certificate don't get this justify thing in the heuristic meaning, so if you don't this in the heuristic way, so this is not working in a technical way in a real world scenario. So this is the hard part of this kind of implementation. So let's move to C, and this makes sense when you propose the proposal. So if you validate the proposers, you need to propose the proposal. So this is the finality to get the next block. So let's replicate this. So you have this self condition, the proposal, the block. You also have this thing, the option. Let the author, proposal author. Remember that this author works like the ID, so a kind of ID, because remember that you have this permissioned settings, so you need to find a way to control this stake. So the proposal, the round. So all makes sense when you in a democratic way propose the proposal to find the next block. So remember that it's all about the longest chain, so all have sense if the longest chain is the chain that have all the IDs, the chain that have all the ways that makes sense with the connections and so long. So this is the finality of this algorithm. So you need to start thinking in the implementation meaning, because remember that the algos are so buggy in the pseudocode meaning, but it's only tricky parts of the code, and there are a lot of people that have incredible expertise in this area, so they make in an automatical way. So let's move to see more things about this chain. In summary, we have this leader reputation that it's all about the inactive and active heuristic, how the structure of this inactive and active heuristic do. Then the process that you need to finally for process the proposal in the last step of this protocol implementation. So another interesting things, it's the mod, and you have that it's all about the modular things that you have in the protocol, that is the leader reputation, the multi-proposal election, is the democratic way for understand the votes and proposer, the pass maker that is very unique in the Libra BFT variant, and in the Hopstop variant. And this pacemaker is all about the struct that have, and it's under the hood. This struct the highest commit round, the current round deadline, and the time service. So far, this pacemaker is an implementation that is responsible for generating the new round and local time apps. So it's a practical way for handle this generating round, and also make a commit membership for the highest now committed round. And this highest commit round, it's for reach the consensus in a heuristic way, in a safety way also, and make a longevity network, and make a liveness concept in the meaning of interpretation of the BFT protocol, and makes sense when you are coding a Python script for make this from scratch, and you saw that your Python script doesn't work like your algorithm. So it's a thing that you need to understand under the hood for have meaning in this protocol specification. So let's go another 10 minutes for understand more things about this liveness concept. So far, in summary, we have the leader reputation, that under the hood is the inactive and active heuristic, that it's a membership thing that have the structure in the Kirin certificate. And we summary the pacemaker that we saw in another videos, that it's the implementation that is responsible for generating the new round and local time of events. So it's a module or instance that made things more easy for handle the highest commit. So let's see the multi-proposer election. That is interesting thing. So let's replicate to understand all the things that this kind of protocol specification has. So you have this multi-proposer. So you have the epoch, proposers, num of proposers per round, back of the proposal, and the backup proposal with the option of this data. So we have here so far all the struct of this multiproposer. So epoch is used as a set of electivity different leaders per epoch. So in this way, this epoch work very similar in the Casper protocol implementation. So ordering of these proposers to rotate through. So all honest replicas must agree on this. So these proposers need to have this vector of this ID that is called in the author. Then the numbers of proposals per round. So you need to keep the highest received backup. And it's another way to protect this multi-proposer for handle the partial asynchronous network. So the implementation of this, imagine that the function of the new epoch of the proposers of the vector of this all kind of input need to assert the conditions that the protocol specification have. And let's see this protocol implementation in the multiproposers. So let's find this as multi-proposer, and there is no protocol implementation of the proposers, so it's a POS protocol specification. So far you can find here the different leaders, the rounds, and so far under the hood you can find here the inactive heuristic wave, the proposer election, its reputation for handle better performance, the protocol specification, the areas of these rounds are divided in 3 because it's very similar with the practical Byzantine fault tolerance, but in a different topology network. So it's an interesting figure for figuring out what is happening when make a chain of view. So let's find this multi-proposer thing for understand the concepts of the Libra BFT protocol implementation. You can find here we can find here a protocol specification of a success rounds in Libra BFT notification to a new leader added in GRI. So we can find here how this is handled. That under hood we can saw that you have the reputation thing for handle this, and the backend thing for the highest commit. So it's a very good way for handle all these things. And in the other case, what happens if it's a failure ROM? And the other things are the timeouts. So remember that the pacemaker have that property of the timeouts setting, and it's a way for process the timeout sender in a channel, and the time service, and of course the time interval that determines the time interval for a round given a number of no commit rounds since last commit. So it's a way for the book the time interval. So let's see in another video more things about Libra. My time is over. Maybe in another video we can see more things about the other part of this folder. And this BFT protocol is so long, so see you in the next video to understand more things.